So what Punch is a mission to image not distant objects in space, but our environment in space. So what we see is space weather. We see something called the solar wind, which is material that's constantly streaming out of the star at hypersonic speeds, up to 1,000 miles per second. Wow. Comet tracking was an immense surprise to us. We thought of comets as something that we'd get in the way from time to time. So the big surprise was we can do new science with comets and their tails. The biggest comet surprise for us was SwRI Atlas. Now, SwRI Atlas is very faint, but because we can track comets continuously, we could accumulate images in Punch and track the comet and measure the evolution of its tail, which was small and faint, but present. So we could determine things about how that comet was interacting with the sun that were inaccessible to any other observatory. We were able to see, right as SwRI Atlas went through the core of the solar system, through the place where it was exposed to the most sunlight and heat, we were able to see that its tail evolved and that there were actual explosions on the comet, eruptive events where the tail suddenly swelled and disconnected. So we know that there were dynamic things happening on this comet as it emerged into the heat from the eternal freezer of interstellar space. The Punch spacecraft will continue collecting data for their entire mission. However, on the ground, we're refining our analysis techniques. We've only recently managed to peel away enough layers of the data to get quantitative photometry, that's measurements of the brightness of the solar wind itself. Punch is currently in the middle of its nominal 2-year mission. However, the spacecraft themselves are designed to last at least 4 years, and they will probably last at least a decade in a usable orbit. So there's a lot still to see as we go from solar maximum through to solar minimum over the next 5 years.